project, I want to start from the artificial intelligence, what it actually is. According to the father of artificial intelligence, John McCarthy, AI is the science and engineering of making the intelligence machine. AI, AI is doing all sorts of automation these days. Like every companies are going towards the AI, from a simple game playing to self-driving cars to a disease detections. AI is doing everything that human can and beyond. These days machines are learning from experience as human does. Like how AI is made of. AI composed of mainly of machine learning and deep learning. What machine learning is? Machine learning is the branch of artificial intelligence that learns from the data without being explicitly programmed. And the deep learning is a subfield of machine learning that deals with the large amount of data. Deep learning is the one of the most emerging field these days, because in the last 2 years alone, the world has 90% of the world data has been created, and it is predicted that 463 exabytes of data will be generated each day by the humans of 2025. So today the topic is facial recognition. What actually is facial recognition, and how it deal with artificial intelligence. Facial recognition is nothing but a way of identifying an individual identity using their photos, videos, or the real-time face. We have been heard the term fingerprint biometric system before. Nowadays, every company is shifting towards the facial recognition system because of the advancement in artificial intelligence. So let's start the project that I have built using the artificial neural network. First, I downloaded the dataset that is provided by the University of Bedfordshire and uploaded it into the Google Drive. Then I connected my Google Drive with the Google Colab. Then first, there are totals of 1500 images that is provided by the University of Bedfordshire. This notebook is also provided by the University of Bedfordshire. I am running this without the careful cross validations at first. By this notebook provided by the University of Bedfordshire, the accuracy was in between the 85 to 90%. But when I changed the parameters, the accuracy increased by a certain percentage. It even reached to 90 to 95% without careful cross validations. So simply by using the matplotlib, there are other visualizations or plotting libraries available like plotly, c1, and so on. University has used the matplotlib, so I will go with the matplotlib here. This is the top 10 images in our dataset. Here using the NumPy, resizing or rescaling the images with NumPy. Then I am saving those data into the NPY extensions file in my Google Drive. Then I am loading these files from this path using the NumPy load function. Then in here I am using scikit-learn selection. Scikit-learn selection is a train test split for splitting the data into training and the testing set. Classification report for generating the accuracy F1 score or precision score report. PCA, principal component analysis. PCA for dimensionality reductions, like it is used to reduce the dimensions of the large data set into the smaller one. Then MLP classifier, multi-layer perception classifier for fitting the model. Like in this case, data set is split into training, X-train, X-test, Y-train, Y-test. Like 20%, 0.2, which is the out of 100, 20% of the data is used for testing and the other is used for training purpose. Here I am doing the PCA with the 20 parameters for 200 parameters for optimizations, and fitting the PCA with those parameters. Applying the transforming the training and the testing data with the PCA. Then in this case I am using the 200 number of hidden layers as 200, and fitting the MLP classifier with solver SGD. SGD is nothing but a stochastic gradient descent activation functions, and activation as a 10H, batch size as 256. In this case, I'm getting the accuracy. That is the accuracy classic. Here is the classification reports that I'm getting the accuracy of 90% in this case. So let me change the parameter as this as 250 and go with number of weekend here is 500. 500. Sorry, I need to run this first one first. Okay, it's run. Then this one. It takes some time because I am given a 500 year layers. Here the accuracy is, for the now the accuracy is 90%. Let's see how does it improve with change in parameters. Like accuracy is 92%, and this goes like I have changed the sum of the other parameters as well, and I successfully achieved accuracy of up to the 95% without k-fold cross validations. Like I have also done with the k-fold cross validations here. Same process goes for here as well. Like loading the data from my Google Drive, then using the train test split to split the data, classification report, MLP classifier, same classifier that multi-level perceptron classifier, and plotly or plotting. PCA, I'm applying the PCA with 250 components here for now. Like we get the accuracy of 92% there. Let's see how it increases. Same functions like 550 hidden neurons for here. This process is with k-fold cross validations. Here I have given the validations, hidden layers for both early splitting, and the loading rate is well. This goes like this one, like 0.95. The accuracy increases with 0.95. Previously it was 0.92, but now the accuracy increases by 3%. Like number of k-fold cross validations, I have given the 8 folds. Like let me try the 10 folds with 50 for now. Okay, like we get the accuracy of 95% there. So let's see how much it goes. It's running. Now accuracy is to 96%. This goes like that. And this is the ANN process for recognizing faces with artificial neural networks, and I have also done this using the convolutional neural networks by using the CV2, and for now I am collecting the data. I am not using the university data because it has there are less data set. So the convolutional neural networks need a more number of data set to get the more accurate results. So I am collecting the data by myself, and by using the CV2. This is cascade classifier, which is nothing but the CV2 classifiers that detects the faces. So let me simply capture my data using my own video capturing here. So simply I need to run this one. Let me run the Python 3 data collections file. So I am storing the data in this path inside the images path. So it will go like this. I am collecting the data. I am collecting 30. I am capturing the 30 images for now. Count equals to 30. I am given here. Count is equals to 30. So there must be a 30 images inside this folder. Images like this one. So here are the 30 images that I have collected right now. So for training the model, I don't have that a good system to train my model. I don't have a GPU for now. So I have trained the model in Google Colab. I'm using Keras in the VGG19. I'm using the transfer learning techniques for training the models. I have trained the models with in VGG16, VGG19, and the ResNet. So So first let me show you with the BGG19 model. So simply I am giving a path to my dataset, training and the testing datasets that are inside my Google Drive. I have uploaded those datasets that I have collected previously into my Google Drive. Then the image size is 224 by 224. Then this is the BGG19, which is the transfer learning technique. I am using the transfer learning techniques here for BGG19. So weight is the image net. Image net is a collection of large number of data sets that it's like a competition. They organize and they collect the large number of data set and train on that data set. So I am using the image net in here. I am speaking the existing weight to the train because this image net is already trained, so I don't need to train that again because it has lot of complexity. Then I am using the globe functions to look at all the files inside my train folder in the Google Drive. Then I am flattening, and then the output that comes from the BGG19 here is flattened here, and the last layer is added using the dense function. Using the dense functions here, last layer is added, and the activation function is used with the softmax. This is the last layer, dense one is the last layer that is added. The 4 is our classes. There are total number of 4, like I will show you, so that there are total number of 4 classes I have in my dataset, like train and the test loop. This train 1, 2, 3, 4 classes here for the 4 people. Then telling the model what the cost optimization methods to use, loss, cross entropy, categorical cross entropy as the loss functions, add-on as the optimizers, and we are focusing on the accuracy matrix. So in here the image generator by using the flow from the directory. This one I am getting all the data stored inside the training and the testing directory. For the training data I am performing data augmentation using the data generator, and for the testing data I am only re-scaling the values. Like there are 618 images belong to the 4 classes in the training set, and the 120 images belong to the 4 classes in the testing set. Then I'm fitting the model with the training set and the validation as a test set. Number of epochs will be 5. The more the number of epochs, the more it takes the time. So the model takes nearly 20 minutes for training here. The accuracy is 0.99 for the training data, and the validation accuracy is 0.92. So it's quite overfitting for now. So now I'm simply saving the model to my Google Drive. So let's see how it performs. Okay, I downloaded the BGG19 model by using the Keras. I'm loading it. So this process like capturing the faces. Process goes like capturing the faces. Then here I'm giving the probabilities. For now testing I'm giving only the 2% of the 2% probabilities. Like if the probability is greater than its solution. Now let me simply change to 0.5. Let's see how does our model performs. Recognize item 8 recognitions faces.py. So let me check. It's loading. It's saying no face matches. It depends. This is me. Errors. It's giving a quite accurate result. Okay, this is Neeraj. No face is found. So if I go back from here, like it simply says, system is quite slow, that's the reason. It's doing the thing, lots of processing going in the background. No face found. I will show that with my photos as well, whether it's detect me or not in the photos. with my camera. Okay, this is saying me nuisance. Now it's correct. It's saying me mirrors. Yeah, this is mirrors. This is mirrors. Okay, that's fine. You can see the probability is down here as well. For persons probability is down here. Let me see if it detects me after I wear the mask. This will take out. Okay, so now it's not detecting faces. It can be done later on by applying the advanced techniques. Matching faces found here. So simply this much from my presentation, and this model can be improved further in the later future. Thank you.